All right. Good morning, everyone. So today what I wanted to do was I wanted to take a second and talk about what does it look like when I'm solving and I have these extraneous or these extra solutions. So remember, as a quick review, right? Extraneous solution, it's something that appears to work, right? But if I plugged it back in, it makes a denominator equal to 0, right? So this is something where maybe it looks like when I solve it, right? Oh, x equals 2, that's great. But then I look back at my original equation and it turns out, well, x equals 2 makes one of my denominators 0. So in reality, it's not an actual solution. So I wanted to go through an example today in this video, so hopefully it makes a little bit more sense to you. I plan on doing a couple more of these as well, so hopefully that's helpful. But if we take a look at the example that's in front of us, right, my step 1 is still going to remain the same as what we talked about yesterday, right? So step 1 is factor. Now, luckily for me, in this particular case, well, this entire thing is already factored. Oops, x minus 1 over x minus 3. This whole thing is already factored. I don't have to do anything. But I'm going to add something to this. State my excluded values. Now, what these are, right, excluded values means what makes my denominators currently equal to 0. So if I take a look at this example, well, x equals 3 is a problem, right? That comes from this factor right here. And for this denominator, that's just x equals 0. So I know x can't be those things. Otherwise, right, I end up with a denominator that's undefined. That's a problem. So when I look at my final answer, I'm going to check against these, right? Is one of my solutions one of those values that doesn't work? If it is, then I just get rid of it. If it's not, then it should work and be just fine. So hopefully that makes sense a little bit, right? It's an easy way to go backwards and then just check against, okay, do I get x equals 3 as a solution? Well, if it appears to be, I know in this particular case it's not going to work. Right? So then if I come back to my steps, step 2, still going to be multiply. Right? So here, let me recopy this down, and then we can multiply both sides. Now, when I look for my unique factors here to multiply by, right, I only have 2, and I'll write those in a different color here. The only 2 are x and x minus 3. So I'm going to multiply by that, right? When I distribute, this loses the x minus 3, but I gain the factor of x. Here, that second term loses the x, but gains the x minus 3, right? And now my last factor here equals, well, I lose the x minus 3, but I gain a factor of x. Now, if you notice something, right, one of the biggest giveaways that you may have an extraneous solution is something like this right here, right? I end up with a quadratic on that side. So this is one of the giveaways that maybe I have an extraneous now. Right? If you end up with a quadratic, it is possible that you have an extraneous solution. It's also possible even if you don't have a quadratic. However, I found that in most cases, if you end up with something like this, where you're going to have an x squared, the likelihood of one existing increases significantly. Right? So I'm going to take this onto the next page here just so we have a little bit more room. Right? I'm sorry, also I have some stray marks down here. I don't mean to bother people. I know with my own OCD sometimes that that bothers me a lot. So now if I go to the next page, right, so we had 2x plus x minus 3 equals x minus 1 times x. So now my third step of simplify and solve, still the same, right? Except for now, obviously, I have a quadratic. So if I simplify my left-hand side, that's just 3x minus 3. If I simplify the right-hand side and I distribute the x, I get x squared minus x. Now, again, if you remember, factoring a quadratic, right, or to solve a quadratic, I want to make it equal to 0. This one's going to be factorable. So if I move the 3x and the negative 3 to the other side, I get x squared minus 4x plus 3 equals 0. I can factor this now into x minus 3 times x minus 1, which then gives me two solutions. I get x equals 3 or x equals 1, which is great. But if you remember, taking a look back to my original problem, this guy right here, 3, he's one of my excluded values. It makes a denominator 0. So when I go back to look at my final solution, well, turns out x equals 3 is an extraneous solution, right? This is extraneous. I know it appears to work. All of the algebra I did here was perfectly legal. I did nothing wrong. But it's just the nature of the fact that in reality, in these graphs, right, that's a vertical asymptote. That's a vertical asymptote. When I multiply by this guy right here, I'm eliminating all of that stuff, and I'm actually changing what my picture looks like. Right? So 3 appears to work. Turns out it actually doesn't. So now my only solution to this problem happens to be x equals 1. So to recap all of that, right, none of the algebra steps that we learned from yesterday change. You're still going to do the same thing. The extra added step I'm going to say is this part right here where you're going to state your excluded values. I think it's helpful because then when you look at your final answer, you can always reference back and say, hey, wait a minute. Is one of my potential solutions one of these excluded values? And if it is, then you just get rid of it. We don't consider it because I know it's going to make a denominator 0. Right? But other than that, everything is the same. Factor what you can. Multiply both sides by all of the unique factors. The only difference is going to be at the end now, I have to look at these two numbers and figure out, is one of the things that falls into my extraneous category or not. So I hope that was helpful. If you still have questions about that, please let me know. It's something that we'll go over at a Google Meet later on this week, probably Thursday, if I can fit it in with my daughter's nap schedule and all. But I look forward to hearing from all you guys soon. See you later.